So in the last video we talked about how to find the zero or the x-intercept of a function, and we found this x-intercept here, and it turned out to be approximately 3.19258. In this video we'll talk about if I have a function and I want to find the derivative at a certain x value, I can use the calculator to get a numerical estimate of that. Alright, so in this case I want the f prime of this x value, and of course this function would be pretty easy to find the derivative of, and then it's just a matter of calculating using this decimal, but it's still, this example still serves the purpose, so we'll just use this. So I still have the function in my y1, and I like to type it into y1 just so that I only have to type it once, and if I use it multiple times I don't have to worry about mistyping it. A lot of these functions you can type it directly in, so there's no reason you can't do that. So when I go to find the derivative, I'm going to do alpha f2. You can see that number 3 is numerical derivative. Hit enter there, and when it comes out to the main screen it really looks just like we would write it. So it's ddx, and I want the derivative of y1. So here again, this is where I can type x cubed minus 8x minus 7 directly in here and it'll work fine, but rather than risk mistyping it, I'm just going to use alpha f4. That gives me y1, and remember in the last video I saved my x-intercept in as the variable a, so rather than have to retype, in this case this is I actually can't remember if I rounded this or truncated this, but it's rounded off. It's not the full decimal, so I would want to either refind it and retype it. I don't really want to do that. I saved it in there for a reason, so I can just go alpha a. This extended decimal value is saved in as variable a, so when I hit this I get 22.5777, and that is the slope of my function at that x value. That's the derivative of my function at that x value, at least a numerical estimate of that.